Alright everybody, DBA2 review. I'll try not to take up too much of your time. We'll try and get through this as quickly as possible because there's a lot of stuff, from what I was seeing from what you guys are doing on Friday, there's a lot of this stuff that you already know, just based on what I was looking at there when I looked at your work when you did hand it in. There's just a couple things I'd like to talk about, and let's get into those. Now, from what I saw here from question number 1, it looked like you guys are doing a fantastic job with graphing the linear functions. So I won't go into much detail here. Just remember that your first step is to plot the y-intercept. So when you're looking at the equation y equals mx plus b, remember the y-intercept is always that b number right there. And so in this case, that b number playing the role of b, make sure you lump the minus sign in there, -4. And that, remember we talk about plotting that y-intercept. The y-intercept always is a dot that goes on your y-axis right there. Boom, there we go. And so then the next thing we have to look at there is a slope. And when you're reading that m number, just remember that the m for slope, that also means rise over run. So when you're looking at this particular function, just keep doing what you guys have been doing. A great job of looking at that 3 and treating it as rise over run. It's going just up 3 into the right 1, so you just put in those other points there. So from here we just go up 1, 2, 3 into the right 1. And then we can just rinse and repeat. Just like that. Muy bueno. Let's look at the other one. Now when it comes to graphing the parabola, a couple things that we still need to have a good grasp of is being able to pinpoint that vertex. And we've talked about that opposite and same game quite a bit here with vertex graphing. Let's just highlight it just one more time. In order to plot the vertex, you need to have an x-coordinate and a y-coordinate to know where to plot it. This is a little bit different than graphing the line. When you guys are graphing the line, you always put that first point right on the y-axis. It's not the case with a parabola. We got to be able to find an x-coordinate and a y-coordinate. So let's go ahead and get those. So when you're trying to get the x-coordinate, remember the key to finding that x-coordinate is looking right in the parentheses of your function. So when we find the x-coordinate, take a look at that number that's inside the parentheses. In this case, the number playing that role is that +3 right in there. So we just take the opposite of that number there. Alright, there we go. So we got the opposite. We want -3. So our first vertex point, or only vertex point, we have to go 3 to the left. And then we play the same game with k. So now that we have the vertex, we're just going to go ahead and plot that point. So we'll go 3 to the left, 1, 2, 3, and then go down 2, 1, 2. And there would be our vertex point. Now to plot those 4 other points, and this is where some of you guys are kind of just missing it just slightly. So remember, we start with the vertex, go to the right 1, and then we can go up 1, we can put a point. And then since parabolas have some symmetry to them, we can go 2 for 1. If we went to the right 1 and up 1, we can go to the left 1 and up 1. Boom. And then we go back to the vertex. Unless we're forgetting to do that, go back to the vertex, and then you can go 2 to the right. And because it's a parabola and we have a squared relationship here, we go up 4. 2 squared is 4, right? So up 1, 2, 3, 4. And then we have 2 for 1. Back to the vertex, 2 to the left, up 1, 2, 3, 4. There we go. Now for some real artistic work, since I forgot my drawing board at home, I'm about ready to draw this parabola. So if you're struggling with drawing the parabola and getting that curve to look straight, the only tip I can give you is, you draw a mustache on some pictures that you guys have done in the past. You kind of, when you draw a little mustache on somebody, you kind of go whoop, like that, and then you go the other way like that. Looks fantastic, right? So do the same thing. Start from the vertex and go up here, and then go back to the vertex. Rather than make that U shape from top and then down below and then back up, just start from the vertex, kind of like making a fake mustache. I had to pick this guy because it doesn't really work on this guy anymore, now does it? Alright, so questions 2 and 3, these ones are very similar problems. I want to see if you guys can take a real world situation and be able to translate. You guys have been doing a good job with that, so let's just take a look at those answers and I'll just elaborate from there. So notice something on both these problems. Both these problems have something in common, and both these solutions have that minus sign in there. And remember how we get those minus signs in there is when they're talking about writing the function to represent the number remaining. Notice both of these, they ask for the cookies remaining, or the distance remaining. That remaining stuff is a good giveaway that you're dealing with subtraction. Secondly, notice that the rate that we're going at, whenever they mention that rate of 3 cookies per minute, or going at 60 miles per hour, notice how we use that and how we translate that. That's always going to be paired up with your x. And always remember too with these problems that if you get stuck someplace and you're not quite sure what the answer is going to be, pick a number. What if you made the cookies for 10 minutes? How many cookies would you have left? And just plugging in the numbers that way can really help you get a good feeling for whether or not the expression you wrote was going to be right or not. Okie dokie, on to 4. Didn't look like anybody had any problems with these. So just remember your big 5 right here. Kind of treat this tomorrow just like it's a multiple choice question with just 5 choices. You have constant, linear, quadratic, cubic, and square root. And all it depends on, in order to determine which one it is to focus on what's happening to x. Notice on this problem here, eventually x is going to be squared. Right? So that one's going to be quadratic, because we have a x being squared there for the general rule. Now we look at the next one there. The next one here, notice that x is being cubed. Well, right here is where x is being cubed, so we have cubic. And last, that one right there, notice that x is being, actually it's being raised to the first power there. Just like this one, x is being raised to the first power. That graph's going to be a straight line, so we have linear. Great. So I'm not predicting any problems here. Quick question here. What would it take, how would you know the answer would be, for example, a constant? Notice we didn't use constant here, but give me an example of a function that would tell you it would be constant. Yeah, maybe something like this, where it's just a function and all you have there's a number, no x attached to it. Alright, now on to number 5 here, looking at this problem where I want you to evaluate, which means find the value. A couple things I noticed here with this one. To get the final answer, make sure that you're using the negatives in there when you're looking at the power properly. One big mistake that I was seeing on quite a few of your papers was I saw a lot of this. So take a look at your papers. You might have noticed me marking that on a few of yours. Is to go a little bit further with this. You substitute the numbers, which is exactly what each one of these situations are supposed to do for the first step, but what you still have to do is find the value. You haven't evaluated this yet. So this is another thing I want to talk about. Some of us might have goofed up a little bit here. An easy way to get this right is remember your order of operations. The first thing we have to do here is exponents. So the first thing that needs to happen in all of these, you got to take the number you put in there and square it first. Now be careful. If I were to ask you guys, without using a calculator, you tell me what -3 squared is, I bet you a lot of you will be able to tell me that the answer is +9. But just remember, when you're using your calculators, bad things can happen when you don't use those parentheses, right? Big no-no right here. We are not trying to type them in like this, right? No good. Instead, we want to type it in just like this. Okay, we want to square that -3 and have it tell us 9. Since you're using the calculator, why not just use the calculator for the whole thing? So notice here me just typing the whole thing in there, getting my +9, and then multiplying it by -7, giving me -63, and then adding 10 to it. Now I'm at -53, the correct answer. So here's the correct answer for all these if you're doing them properly. So notice squaring the numbers there would always give us a positive number, rather than the number that we put in there was positive or negative, and then we got to multiply. Then we just add. And there we have it. Let's take a look at some new problems. Now, domain and range I'm not too concerned about. Remember, for the domain it's just your x values, so just list them out. And then the range is just the y values, list them out. Just remember, if you get numbers that repeat, like that 6 right there, you only need to write it down once. And just another easy way to remember domain and range, x comes before y in the alphabet, so does d. D comes before R in the alphabet. Alright, looking at number 7, determining whether a relation is a function or not. You guys are doing a pretty good job with this. When you're looking at it in table form here, what was the only thing that you really needed to focus on to figure out if it was a function or not? Yeah, you only needed to focus on just those x values. If the x value is repeated anywhere, then it's not a function. But if you don't see any repeated x values, then it is a function. So looking at A, definitely a function. And don't forget that explanation part there, that the x values don't repeat. That's just as important, because notice up here we are going to be looking for you guys to explain or demonstrate why or why not, and that's your explanation right there. We look at the second one and look at B there. That's definitely not a function, because when you look right there, those x values repeat. All right, great. Now what about that C right there? Just written a little bit differently. Just remember, if we're only focused on the x values there, can you find the x values when it's written this way? Sure, not a problem. You look at those, -3, -1, 4, 5, 7, no repeats. So guess what? Function. Let's look at the next one. The only thing that's different here is that now that it's a picture instead of a graph, we have a different way that we can test to see if it's a function or not, but it's very similar to x values repeating. If an x value were to repeat, that means you'd have that one x value going to more than one value, and it looks something like that circle over there. Notice that when we use a vertical line, we hit that graph twice, and when a graph does that, that means we're getting repeated x values, or the domain is repeating. So once again, this is not a function. Now if we look at the other one there, the parabola there, notice that no matter where we put this vertical line, if I drag it along here, notice we are only hitting that graph once everywhere. And if we can hit that graph once, that means it is a function. Alright, let's look at some more. Alright, looking at this problem, I'm not too concerned about this one, mañana either. Just remember, when you're looking at this graph, find the key points. Remember, key points are when it crosses the grid lines. The vertex is a good one. And then you graphed a parabola earlier, it was over 1, up 1. And then maybe over 2 and up 4. Notice we land right at the x-axis this time. So let's just take those key points. Let's move them 6 to the left, and then we'll move them 3 units down. So each one of these, so we'll start the vertex. 1, 2, 3, 4, 5, 6. Was that 6? Yes, it was. And then we'll move them 3 down. 1, 2, 3. There we go. Do the same thing for these other points. 1, 2, 3, 4, 5, 6, down. Wait a second. Why move the rest of them? If you knew the parabola was going to have the same shape, why don't we just go over 1, up 1? And then from here go over 2, and then up 1, 2, 3, 4. That'll save you some time, won't it? 2 for 1. There we go. Mustache again, right? Let's look at another one. Alright, getting closer to the end here, just looking at these ones here. 2 things I want you guys to do. The first thing I want you guys to do is to name the parent function. We did that a little bit earlier. Remember the big names there. Constant, linear, quadratic, cubic, and square root. So I want you to do that for those. Alright, great. Now that you've named those, now the second thing that you have to do is I would like you to tell me the transformation that we did when you compare it to the parent function. So you're going to need to have a good understanding of where the parent functions actually originate from. So we bust out these graphs here again. Notice that the quadratic parent function has a starting value right there at 0, 0. Now we're over here at -2, 0. So now it becomes a pretty easy question to answer as far as its transformation. We just did a translation 2 units to the left. Square root function, whoa, whoa, whoa. If we notice the square root function here, originates right there at the origin and goes off into the right. Notice now we're at -2, 0, and we go off into the right. Still keeping that same pattern, right? The square root of 1 would be 1. The square root of 1, 2, 3, 4 would be 2, and so on and so forth. So now we can name this one as well. We just did a translation on that one also. 2 to the left. Alright, looking at number 11, I already put the solutions up there, so let's just go over what we're supposed to remember when it comes to doing all these transformations. Whenever you're being asked to reflect across the x-axis, like I said before, make sure you picture that coordinate plane. And then just mentally ask yourself, which direction does it go when you want to reflect something across the x-axis. Notice that when we take this and reflect it across the x-axis and move it right down there, notice it's the y coordinates that are changing, not the x. We're just going back and forth from, let's see here, from here to there, here, and there. So we are just doing reflections. So make sure that when we are doing those, make sure that we are changing those y coordinates. Notice that's all I did there, is I kept all the x's the same, and the y's just changed to the opposites. And you guessed it, now that we're reflecting over the y-axis for this next one here, when you take something reflected over the y-axis, it's actually the x-coordinate that changes. So it's me double checking my work, just to make sure I change the x. So if that's -2, I need a +2. If that's +9, I need a -9. And if that's -2, I need a +2. Now it's double checking the y coordinates, make sure I didn't change those, and sure enough I didn't. Now, if I want to do a horizontal stretch by a factor of 2, I want to widen where that point is in relationship to the y-axis. So if I have a point right here and I want to stretch it by a factor of 2, which means I need to double its distance. So if it's already 2 away from the y-axis, I double it, and now it's 4 away from the y-axis. So now what we're going to do here with all these points, here, 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 all those x's, is we're just going to take those and we're going to multiply them by a factor of 2. So now it becomes -4, it becomes 18, it becomes -4. And notice the y coordinates just stay put. Now when I want to do a vertical stretch, multiply by a factor of 5, it's going to get taller, it's going to move away from the x-axis. Notice that I'm already at -2,4. I want to make it 5 times as large, it's going to end up maybe someplace way up there. A good way of picturing it is just taking these y values here, and here, and there, and multiply them by 5, by 5, by 5, and leave the x coordinates alone. Alright, so now the parking question. If we are charging $10 to get in and $3 per hour, they wanted to make a table for the total cost. Try not to overthink this thing. Just put those 5 values right there in your table for the x, and then go through and get your y's. But what you have to remember when you're filling this in, and be extra careful of this, is make sure that you're adding in the $10 entrance fee. Because remember, we're looking for the total cost here. So for your first value there, we're looking at a total cost of $16. 3 times 2 for the 2 hours, and then we got to add in the $10. Let's fill in the rest. And there you have it. So part B, 48 hours, you guessed it. Aren't we essentially doing something like this? Take the 10 plus 3 times 48, which would give us the $154. So now to get to the next question, writing a function to represent the total cost, take one real good look at what you just set up right there, because that's really telling you what the function's supposed to look like. Which will just look like this. Just get that 48 out of there and just put x in its place. So there we have it. So finally, to wrap this up, identifying all the following parent functions, just having a good idea on that note sheet of those 5 functions. All I'm asking you guys to do is just to give me the name for all of those.